It's almost like a full moon day, and I wanted to actually image planets, but I changed my mind and I wanted to do something with RASA and see how the narrowband filters behave when it is almost like full moon. I'm not taking pictures close to the moon, but on the other side. Did you guys see my video on the Saturn? So that was my Orion Nebula moment when I took the picture of the moons of the Saturn. So when I first took a peek at the Orion Nebula using my telescope, I was looking at it and I thought I was looking at a cloud. I didn't realize I'm actually looking at Orion Nebula. And once I figured it out, I had to run, bring all my family members, show them, see what it is. So when I was taking pictures a couple of days ago of Saturn, and when I looked at like close to the 10 moons of Saturn, I was like, oh my God, this stuff is real, right? So I think those are the moments that we go after, why we actually look at the dark sky and why we look at the planets and nebula or whatever. Actually today I wanted to take a picture of the Tulip Nebula. I thought it's pretty cool, actually try it out. Moon is on this side, the nebula Tulip is going to come somewhere here, so that actually it stays away from it. And you have to use dew shield to make sure that you don't grab. So I'm doing all the stuff that I can. So yeah, a couple of things I wanted to talk about is how to focus your telescope, right? So if you are new to imaging, this stuff would be very helpful. But if you are doing it for a while, and if you bought yourself like a RASA or something where you don't get the V curve working for RASA, this probably is going to be helpful to you. So Bahtinov mask is still a pretty good option if you are trying to do focus. I think that gives you rough focus that you need to start with. The trouble comes in when you are using narrowband filters. Narrowband filters tend to actually show less number of stars, and the stars that are bright are visible, but the stars that are faint are not visible. So once you usually focus using like a Bahtinov mask, usually my second step is to look at the live view software, like I use SharpCap, and go to like those tiny stars and make sure that they are small, not like out of focus or big. Usually I make them magnify like 200% and make sure that star is small enough. But if you are working with narrowband filters, I don't think that trick is going to work, because those tiny stars that are faint won't even show up on the narrowband filter. So what do? Well, the way I do it is I go into the Sequence Generator Pro and I put like a 15-second exposure time, and I will actually start taking pictures, right? I can delete them, but I'll start taking pictures of those 15-second exposures, or even just continuously loop that for 15 seconds, it doesn't matter. And zoom into an area where you can see tiny stars. Those tiny stars are always visible when you do that 15-second exposures. And if you can see and focus those tiny stars, like make them from a bigger star to a smaller star, I think you get like really good focus using that one. I tried several times and I think that trick actually worked. I mean, I tried 5 seconds, 10 seconds, but 15 seems to be good for me. I think, depends on how you are imaging, what kind of sky area that you are in. So look at it. But as long as you can see the faint stars using your narrowband filter, I think that is the trick and that is the way you need to do it. Zoom into the area after that 15-second exposure, and when you keep it in the loop, it still shows the same area, so you can see whether the star is going smaller. So I was surprised actually to have a pretty good focus using that method. Of course, I'm still using the Starizona Micro Touch focuser, but I can use that remotely, like inside my house, and then focus it the way I wanted it. I think that takes like probably like 5 minutes or so. It depends on the time, but anyway, that stuff is going to work really well. And see if I can capture the Tulip Nebula when it is close to 100% moon. There is no signal at all in O3. So I have my bias integration file right here somewhere. Yeah. So this is my bias integration file. For O3, I have to use the flat. So I will go to O3 bias corrected 1K flats. So I took a 1K, like 1000 ADU O3 flat, and they are bias corrected. And I put that here. So these are the two. You can see my settings here for my image calibration, and that is pretty much it. So those 33 frames are going to get calibrated right now. Okay. So if I go to O3, I have these 33 files calibrated already. So the next step I would do is star alignment. So for star alignment, I use my HA frame, like one of the HA frame as a reference. So if I go to this is the frame I was using for a reference. It doesn't matter. You can pick a frame for reference. A good frame that is the way you wanted it is better. So my O3 files are here. These are the calibrated ones. And I will create a directory called star alignment right here. And apply. So this will create a star aligned or a registered files. All right, star alignment is done. So when I need to integrate these files. So when I was doing it, I clicked on the drizzle. So it actually added the drizzle data as well. So I have to add the drizzle data. You can see my settings here. This is for image integration. There is no signal at all in O3. So I'm just using that to create a combination image between. All right, image integration is complete. Just seeing if anything is bad. Yeah, as I was telling you, there is no signal at all in O3. So I'm not expecting a whole lot of stuff coming out of this one. Obviously, it does not matter. Anyway, so this is just the O3 data. I don't even need to drizzle this one, honestly. Since there is no signal anyway. So I'll just make this as O3 for now. leave it in there. My HA, however, I did the same process, and HA files are here. Alright, so these are my drizzle integrated files for HA. So I put scale equal to 1. I'm not doing a integration to make the file big. I just wanted to make it look good, that's all. Alright, so let this process keep going for a while. So here is the drizzle integrated file. You can see, yeah, it got a lot of signal. The HA got a lot of signal. So this is HA and this is O3. Literally no signal at all in the O3. So I rename this file to HA, and the way I integrate is I use this pixel math formula. This gives me natural color when I have only hydrogen alpha and oxygen. And if I run this process, it actually integrates and gives me this file. Okay, so I can minimize these guys. I don't need them anymore. Okay, so here is my combined integration file. So if I run automatic background, extract, takes care of that, the color stuff on it. And here is the integrated image. This came out pretty good. So the first thing that I normally do is I do a photometric color calibration. Where is it? Photometric color calibration. So I'll take usually the reference image. Okay, so the reference image is frame 99. Okay, and then here I will say acquire from image. So it takes the array and the deck from this actual image, because the integrated image will lose those location. And then before I go far, I think it's not a bad idea to save these files. I don't want to lose them. So this is my O3. I usually save them in XISF format. And I don't need this file once I save it. And save this one to the HA file. Alright, no need for this one. This is before the background. I don't need that one. Here is my file. So I got the location, right? I can actually save this one too, saying that, hey, here is my automatic background file, right? So just in case, if this process is taking time or some other issue, you don't want to lose your work. So drag this one right here. This will take some time. What this will do is, as you can see here, it takes the location from what you provided here, the array and the deck, goes to the database server that of your choice, There are like 6-7 servers here, and does two things. It actually does the background neutralization and it does the color calibration. It performs those two functions automatically without doing any thing manually, right? If this works, usually I use the photometric. If not, I have to do the color calibration and the background neutralization manually. I have to do it. So let me pause here for a second. All right. So the photometric calibration is done. It brings up this white balance functions picture. You can close that one. So now this is what we can do is open the screen transfer function, turn off the stretch, make sure this is unlinked, and click the nuclear button. So it gives you kind of the stretch that you need. And then if we look at the histogram transformation for this file, drag this over, you will see, okay, and if we drag this one over here and turn off the stretch, it gives you like a non-linear image. So you can do a dynamic crop here, because now, since we did a photometric, you don't want to do photometric after the dynamic crop. So generally, you wanted to keep the image the same as what you acquired. And then, alright, so this is the cropped image. Since we used RASA, we can go and do a horizontal mirror of this file so that it creates what we need. I think there is some more stuff here. We can get rid of a little bit more. Okay, so that gives us a little bit easy to process, right? So all right. So we need to get rid of this noise from the background. So there is a process we can use called TGDV noise function. Those are the settings by default. So this is before and this is after. I think that's pretty good actually, before and after. So that's not too bad. Now you don't want to do any increase in saturation before getting rid of some of these things. So if you do a HDR, not HDR, if you do an MT, morphological transformation, and make it like 55 or 65%, keep it here, and size equal to this one, erosion equal to minimum, and this will take care of way too much. See all that? It took away a lot of small stars. You don't want that much to be applied. So Still a lot at this level. So I would reduce it a little bit more. Actually, we can try morphological mean median and see if it does change a little bit. Yeah. So this is before and this is after, right? Before and after. I think this is looking better, so maybe we can increase now and go back. So this gets rid of all the noise without creating trouble. So this is before, after, before, after. Let's see at a higher level how it looks like. So this is before and this is after. It gets rid of some of those stars and also some of the noise, and it looks pretty good actually if you use the MT. Okay, so MT is done. The other one that we can do is to apply, yeah, this is after, to apply what we call ACDNR. So this is also another noise reduction process. So these are defaults that I use always, so I kept them in there. Alright, so this is before and this is after. It's pretty good. Right. So this is before. It's very slight change. I mean, unless you zoom in, you can't really see the effect. So when you zoom in so much, then you would see what happened actually, right? I hope it shows up on the video. Okay, so we did the ACDNR as well. There is a little bit of green gradient, but I don't want to change the colors. I can do an SCNR and get rid of the green gradient from this one. So this is before and this is after. Let's zoom in and show you what I mean. So this is before, see all the green stuff, and this is after. It becomes a little bit more bluish, but at least the green gradient will go away with the SCNR function. Alright. So we can do a deconvolution. It's a very long process to do a decon. So sometimes what I do is I turn off, use the defaults and apply and see if it is going to change anything. If the defaults works on the deconvolution, I'll take it. If not, usually I revert it back and move on. So this is before and this is after. So let's zoom in and see what happened. Before, see all that, and after. It becomes a little bit more sharp before, after, right? It gets a little better than what it is. It won't show up that much, like unless you change these are my settings, so always I use them, so I keep them like icons here. All right. So I think we did a noise reduction. We pretty much did deconvolution. We did the morphological transformation. The next thing I do is HDR multiscale transform. So this is my setup here, and I do small scale 0 and large scale. So what this will do is actually it will, all right, let's see. So this is before and after. Before and after. So if I go into the details, before, it's like kind of after. It gives you a pretty good image after that is done. So now if I save, I need to save this one before I lose it. So this is, I usually put like what I did. So if you go into the History Explorer, you will actually see what we did to this file. So we did photometric, histogram, dynamic, fast rotation, dynamic, TJVD noise, morphological, ACDNR, SCNR, decon, and HDR multiscale transform. Okay, so now the next step is to the curves transformation. Do a saturation, check that box. Bump up the saturation a lot. That gives you all that red stuff that you need. Okay. I would say that's pretty good. Okay. And apply that. Okay. So that gives you a pretty good color to that tulip. Oops. See the dark there? That's not good. So this is happening because of my decon process. So decon process, HDR multiscale process did that. So I don't want HDR multiscale to do anything with it because it's creating that stuff. So anyway, if I take that one, yeah, sometimes you have to go back to see who caused that. That's okay, we can reduce some of those effects when we do a RGBK and tone down a little bit. Yeah, not to lose the background. Okay. So this is before, this is after. Okay. All right. So it gives you pretty good data to work with. Now, what we can do is go into color saturation. See that? You see the, yeah, it reduces quite a bit. And also I'm trying to remap it to the green so that becomes more of a black than a blue. I don't know if you can see all what I'm doing to that color so that it brings this nebulosity out. That's my try. Okay. Alright. So that takes care of that. I'm trying to bring these nebulosity out right here, like this stuff. So it's like right there. You see that? The difference between these two? It pops up a little bit when you saturate that one. So this is before and this is after. Let me zoom in and show you. So this was before and this is after, right? It shows those edges a little bit better, right? So, okay. I don't have to do that anymore. See if we need to do a little bit more adjustment on the subtle picture as a whole. Okay, I wanted all that stuff to come out, but I don't want. Come on. Okay, so here is how it was. Okay, we can do before, after. Okay, so I think I got everything out of the woods. There is no more signal. I think I saturated the most of it. So this is before, after, before, after, before, after. Okay, so what I realized was this is a little bit too much that I'm trying to bring out. So I can reduce this, tone down a little bit. Oh God. So tone down this one a little bit less. And okay, that's the maximum amount of signal I could extract from this picture. I think there is no more juice left for me to process. Another thing that I'm thinking is to reduce some more stars. So I go back to the MT. I leave it as erosion minimum. Reduce this to like 34 or something. Look at what happens when you apply that. When you do like a 34. So this is before, after, before, after. It just reduces the eye-popping color a little bit. So this is like before, too many Stars are bright. This is after. It just brings more nebula out rather than bringing the color out. I mean, if we keep applying it, it's going to mess up the picture. So this is like before. So let's see what happened to the picture. After. It should be fine. Before, after. So this is mainly to present the picture before, after. So here is, I think this is good. Maybe a little bit of more crop is needed. A little bit, not a whole lot. All the edges. Because the edges will still have. Yeah, I think that will do. I hate to remove anything on this side, so I'm like, I really don't want to do that. There isn't much on this side, so I don't mind at all. So, all right, that's my final image. I think it is the best I can do for now. I hope you got something out of this. So here is where we started. History Explorer, initial state. So let me open up the original image. Is here somewhere we started with the ABE. So this is where we were. Oh God. This is where we were when we started it, somewhere in that ballpark, right? Here is where we ended up. We brought in quite a bit of details from this picture to here.